Hello, in this video we're going to talk about conservation of momentum, what that concept means, and how to solve math problems involving conservation of momentum. If you haven't already watched a video on momentum and impulse, I would recommend watching that first so you have some background. First off, what are the content and the language objectives for today? The content objective is I can solve math problems involving conservation of momentum. Language objective is I can write about how a rocket demonstrates the law of conservation of momentum. First, conservation of momentum. What it is, it's the idea that momentum cannot be created or destroyed, only transferred or transformed from one circumstance or one object to another. An example of that would be Newton's cradle, that transfers momentum from one ball to another ball to another ball and continues moving back and forth. When you are trying to solve conservation of momentum problems, what is often done is you write out a situation shorthand. And so, in the example of the skateboarder here that is pushing off and moving along, you have these different symbols. And what they stand for: P stands for momentum, I stands for impulse. So, momentum, mass times velocity, impulse, some force, some time. V stands for velocity, M, mass. 1 and 2 represent different objects, object 1 and 2. A and B represent after something or before something. So before and after some event occurs. And then the last symbol at the bottom is a 0. Sometimes there's no movement, there's no force at the beginning or end of a scenario. And so with the skateboarder, if the skateboarder is moving before some event occurs and then pushes off, you have an object that's moving, mass times velocity beforehand. You have a push or a pull, so you have an impulse, and then you'd end up with a momentum of this object afterwards. And so the reason you write out these things shorthand is so that you can figure out what you're solving for, what equations to use, what variables you need to look for. And so just a couple of examples to look through. If you have one object, this blue rectangle that's moving to the right, you have one object that's moving before some time period. You have a yellow block that's moving to the left. Again, you have some object 2 that's moving before something happens. And then if those two objects collide and move off to the right, what you have is two objects, 1 and 2, stuck together that are moving afterwards. And again, if you have values such as mass and velocity, what you can do is you can solve for maybe how fast this 6 kilogram blue and yellow rectangles, how fast that they're moving afterwards. And so you can use the known factors to solve for the unknowns, but you need to know how to plug those numbers in. Another example would be a cannon. So before a cannon fires, there's no objects moving, there's no force acting on an object, and so you have no momentum. But then what's going to happen is you're going to have the cannon that moves backwards and the cannonball that moves forwards. And so you have two objects that are going to be moving in opposite directions with opposite momentum after this cannon fires. And so we'll go through one scenario, just start to finish together. What it says here: a car with a mass of 800 kilograms is moving at a velocity of negative 25 meters per second to the left. The negative is just a keeping track of direction. It says a truck with a mass of 1,200 kilograms is moving to the right. When they collide, both cars stick together and move at a rate of 4 meters per second to the right. It says, what was the velocity of the truck before the collision? So the first thing I'd recommend doing is to draw a picture of what's going on, so you have a mental image of what's happening. And so I just found a picture that represented this, where you have a truck that's moving to the right, you have a car that's moving to the left, and then after they collide, both move together to the right. The next thing you want to do is figure out what is a conservation of momentum scenario. How are you going to write this out shorthand? And so the way I wrote this out is you have the truck that's moving before, you have the car that's moving before. And then at the end of the scenario, just like an example we went through, you have two objects that are stuck together that are moving to the right. And so the conservation of momentum shorthand equation that I have, momentum of one object before, the momentum of a second object before is going to equal, since momentum is conserved, the momentum of both objects together afterwards. And so if you have momentum, from the previous video, you should know that that is a product of mass times velocity. And so the mass times velocity of your first vehicle plus the mass times velocity of your second vehicle should equal the mass of both vehicles times their velocity afterwards. And so if we plug in the numbers from this scenario, what you'd see is the mass of the car times its velocity, the mass of the truck times our unknown velocity of the truck should equal the mass of the car plus the mass of the truck times its velocity afterwards. When we resolve that, what you would see is that our velocity of the truck, before the collision turns out to be 23.33 meters per second. And so again, how'd you do this? Step one is to draw a picture representing what you have happening. 2, to write out that situation shorthand using P1, B, 0, A, 2, all those different variables that we talked about. To then figure out what do you need to solve for momentum or impulse, depending on the circumstance. Setting those before and after equations equal to each other because momentum is conserved. And then you can solve for the one unknown variable, which was the velocity of our truck before the collision. That's it. If you have any questions, again, please feel free to hop on the virtual science homework help times or shoot me an email if you have any questions. Have a great day.